Welcome to Mentivia. In this module, we're exploring how atomic structure and isotopes become powerful tools in forensic science, helping investigators solve real-world mysteries. Hello, I'm Oksana from Mentivia. Welcome to the fascinating intersection of atomic structure and forensic science. Today, we'll uncover how the tiny components of atoms, protons, neutrons, and their variations isotopes, become essential tools for forensic investigators. These atomic details allow scientists to trace the origin of illicit substances, identify unknown materials, and link evidence to specific sources. By understanding how isotopes vary and how atomic signatures are used in analysis, we'll see how chemistry plays a vital role in uncovering the truth behind complex cases. Isotopes, as you know, are atoms of the same element with different numbers of neutrons. While their chemical behavior is nearly identical, their slight mass differences create unique isotopic signatures. These signatures are like a chemical fingerprint, influenced by geographical location, environmental conditions, and even biological processes. Forensic scientists exploit these subtle variations to determine where a substance came from. The process of isotopic analysis in forensics involves several key steps. First, a sample is meticulously collected from the crime scene. Then, it undergoes preparation to isolate the specific elements of interest. This prepared sample is then introduced into a mass spectrometer, a sophisticated instrument that separates isotopes based on their mass-to-charge ratio, allowing for precise measurement of their relative abundances. Once the isotopic ratios are measured, forensic scientists compare this data against extensive databases of known isotopic signatures. These databases contain information on how isotope ratios vary across different geographical locations, climates, and even manufacturing processes. By matching the unknown sample's signature to a known one, they can pinpoint its origin. Let's consider a real-world example. In a compelling case, a large shipment of illicit drugs was intercepted. To dismantle the supply chain, investigators needed to know where the drugs were produced. Forensic scientists analyzed the carbon, nitrogen, and hydrogen isotopes in the drug sample. These ratios are influenced by the specific plant source, the soil it grew in, and the chemical processes used during refinement. By comparing these signatures to a global database, the origin was pinpointed. Moving beyond isotopes, the atomic number, the number of protons in an atom, is equally indispensable. This number uniquely defines an element. By determining the atomic number of an unknown substance, even in trace amounts, forensic scientists can definitively identify the elements present, providing crucial clues about the material itself. Several advanced techniques are employed in forensic labs to determine atomic numbers and elemental composition. X-ray fluorescence, or XRF, bombards a sample with X-rays, causing elements to emit characteristic secondary X-rays at unique energy levels, identifying them. Inductively coupled plasma mass spectrometry, ICP-MS, is highly sensitive, detecting elements in extremely low concentrations in various samples. And scanning electron microscopy with energy dispersive X-ray spectroscopy, SMEDS, provides high-resolution images alongside elemental composition of microscopic particles. Consider a hit-and-run case where tiny paint chips were found at the scene. Traditional methods couldn't identify the vehicle. Forensic chemists used CMEDS to analyze the elemental composition of the paint layers. They found unique ratios of elements like titanium, lead, and chromium. Comparing this elemental fingerprint to automotive paint databases allowed them to identify the exact make, model, and year range of the suspect vehicle, leading to a conviction. In essence, both isotopes and atomic numbers are invaluable in forensic science. Isotopes help trace the geographical or manufacturing origin of materials by their unique ratios, while atomic numbers allow for precise identification of elements present in unknown substances. These atomic-level insights provide powerful, irrefutable evidence, transforming how crimes are investigated and solved. Thanks for watching. If this video lit up your curiosity, head over to mentivia.com, your free treasure trove of e-learnings, videos, and articles covering everything from science to history and beyond. Love learning? Hit that subscribe button and stick around. There's a whole lot more brain-boosting content coming your way.